Hello and welcome. So the government's construction playbook commits to using MMC to the extent that it's now pretty much the default delivery method. Capital projects now have to justify why they're not using it. And if the total MMC percentage for the project is low, you must also justify why this is the case. So what are the facts surrounding MMC? Well, at its best, it's high quality, low waste, up to 50 to 60% quicker. There's less disruption with things like noise, dust, traffic, and potential health and safety risks. And there may be some potential cost savings, especially in the design phase and the construction phase. So NTX and WSP have worked together very recently, and we'll touch on that a bit later. So what are the challenges? Next slide, please. So when we think about capital projects, there are a number of challenges and criteria that we must meet and that are facing capital projects today. So can you relate to the ever increasing capacity challenges facing the NHS due to things like aging population, increased prevalence of chronic disease, comorbidities, pandemics, post-pandemic wait lists? They're all elements putting pressure on the NHS and subsequent capital projects. Do you need to meet strategic targets or clinical aspirations with regard to things like improving patient pathways or infection control? Any solution is going to have to be compliant with health building notes and health technical memoranda, alongside statutory requirements like planning, building control, BIM, BREEAM. You're going to need a building with a design life of up to 60 years. And are you worried that the modular solution might not last? I think we've all worked on a project where we need to minimize program and limit whole project costs while trying to maximize everything else. And usually your project's going to need to minimize disruption to existing operational activities. And finally, and arguably one of the biggest challenges we face globally, how are we going to support and deliver net zero carbon construction? This target will begin to slow down the effects of climate change and aid in healthier populations by reducing a myriad of climate-related health concerns. So if we could just click through the slide, that would be awesome. Thank you. So not much to be getting on with then. So David, what is MMC and how can we best use it?
Thank you, Sarah. Good morning, everybody. So when we think about, over the years, there's been a lot of confusion over the word modular. So what is modular? Is modular a substandard prefabricated classroom that we're all once familiar with? Is it a modular wiring system or a pre-manufactured wall system? Well, thankfully, Mark Farmer, the government champion for MMC, has provided some clarity to the industry on this matter and categorised all preconceptions under one banner of modern methods of construction with the MMC definition framework. So very quickly, category 1 being 3D primary structures such as volumetric buildings. Category 2 is 2D primary structural systems such as SIPS panels and LSF framing. Category 3, components, which would be pre-manufactured staircases, columns and shear walls as an example. Category 4, additive manufacturing, an example being 3D printing. Category 5, non-structural assemblies such as bathroom, kitchen assemblies, pods, MEP service modules or door sets. Category 6, site-led productivity, which could include brick slip, modular wiring systems, flexible pipework, and finally category 7, which would be site process-led site labour reduction and productivity, which would include autonomous plan and site worker augmentation. So the next slide, please. So the Prime Minister recently quoted during a visit to our Hereford project that we need to build better, faster and greener. And in turn, when we do, we're going to achieve the greatest levels of PMV, PMV being pre-manufactured value, which will ensure we build faster and safer, we improve quality, we reduce vehicle movements, help overcome the nation's skill shortage, increase the opportunity to recycle, and all of the aforementioned support net zero construction. So next slide, please. Bride & Woods have produced an interesting graphic which displays the association between modern methods of construction and pre-manufactured value. Trusts are required to update this tracker with progress throughout SOC through to FBC. As with almost all of the projects we're involved in, we aim to maximise the opportunity for MMC, where our offering combines volumetric construction with manufactured and component-led equipment, products and services. This results in a very efficient project delivery, where our PMV value is upward of 60%, resulting in an output which would conclude in the top right-hand quadrant of the graph. So, some myth busting. Next slide, please. Volumetric buildings comply with HTMs, HBNs, planning, building control, amongst many other requirements. Strict adherence to the HTMs and the HBNs is essential to ensure continuity of service throughout the NHS and ensuring patient care is at the forefront of all projects. Of utmost importance, of course, is the correct architectural and building services design to ensure the correct clinical separation and environmental design. Next slide, please. All of our buildings are bespoke and we work with clients to maximise the structural grid and open plan spaces. Next slide, please. The structure of our buildings are constructed from hot and cold rolled steel, and in addition, all additional materials are the same utilised in traditional construction. Volumetric construction can often have a design life of up to 6 years, which is comparable to traditional construction. Next slide, please. MMC can look exactly the same as a traditional construction solution, and we often use the same cladding systems and, of course, the same materials inside the building, including the MEP, FF and E. Next slide, please. And almost all of the buildings we construct are constructed as a medium to long-term solution. And in fact, certainly in my history, in the last 20 years, we've never ever installed a building that still isn't in situ today. Over to you, Sarah.
Thank you. Next slide. And if we could just click on again. So how do we decide on what methods to employ? So this diagram is part of a piece of work put together by WSP's structural team on a health infrastructure project alongside their MEP team and the architect. And this forms a process for navigating their way through differing methods of construction. In summary, it's complicated, especially for a healthcare planner like me. In this specific example, they analysed and scored different structural solutions against different types of accommodation within a hospital. So things like wards, diagnostics, theatres, and then this is weighted according to a primary evaluation category, like maybe cost or sustainability. This process helped the project consider the form of construction, gives it an audited narrative, and helps test the decision-making process. It's important to do this early on in the concept phase to ensure a concept design that plays to the strengths of MMC. If this isn't done, it can rule out options further down the line. If we could just click on again. Thank you. So I guess we could take theatres as an example. Theatres in traditional builds, especially on congested sites, tends to be planned on the upper floors, away from high footfall areas. So away from the ground floor, public access, so outpatients or ED, and conveniently near rooftop plant. But if we look at it through the lens of MMC, designing theatres on the top floor of a volumetric building can be more expensive and time intensive on an MMC build, as you need concrete floors and good response factors. So in order to reduce potential abortive design fees, it's important to start out with theatres in the right place. Ground floor might mean reduced programme and reduced costs, as you don't have to pump the concrete up 3 floors and change the structure to accommodate this. I think for me, it's certainly about balance between retaining that optimum flow around a building and realising the construction benefits of MMC. Okay, thank you. On to David.
Okay, thank you. So often we work with clients from conception, initially working to establish a suitable position within the hospital estate. A substantial amount of our projects initially commenced with a pre-construction commission. Following the REBA plan of work from stage 1 to 3, we defined the brief and concept design. We work proactively with the stakeholders to establish a schedule of accommodation, which later allows for a layout to be agreed. Typically, this process takes 6 weeks, although with more standard projects, we're able to expedite this much sooner. This is an express process to quickly establish the building footprint. Early site investigation, infrastructure and enabling explorations and the appointment of a BREEAM assessor are essential. In terms of procurement, this is achieved via a number of NHS approved frameworks, which include the NHS SBS framework for modular buildings. Clients are able to single source if they choose for speed with one supplier, or alternatively engage with several pre-approved suppliers. Next slide, please. So as can be seen on this graphic, stage 3 is where substantial benefits can be realised. The substructure and superstructure commence in parallel, and this is where there is a big win. And at the time of we're working to finalise the stage 4 design, multiple parallel activities allow for significant reductions in programme, which would typically occur in series on a traditional project. All of our projects, to be fair, I mean, it's often, there are a number of projects which are initially considered as a traditional build, and we get involved and we can actually reduce the programme by up to 40%. Okay, thank you.
Okay, so I'm going to talk about the benefits David mentioned through a case study or two. I'm not going to specifically talk about the project, but look at the lessons learned and the process undertaken. So this was an ICU project in response to COVID-19. So where did we begin? Well, it was a directive from NHS England for a large number of ITU beds. This is a different approach to the demand and capacity modelling that we would usually undertake. But as many of you probably know, that is a historic under-provision of ITU beds across the UK when compared to the rest of the Western world. So in addition to the design, planning was also completed in parallel under the emergency planning powers, as Aaron mentioned, as well as the business case approvals, and a number of orders were also placed in parallel. So we certainly hit the ground running. There were lots of activities done at once. This was a heavily built up site, still needing to ensure short journey times to A&E and theatres and imaging. And this was going to be the permanent home for ICU. And in order to deliver the number of beds required, it had to span a number of floors. Each of the clinical floors is self-contained, with donning and doffing spaces on entry and exit to each floor. This ensures staff do not need to leave the floor in order to grab supplies once gowned. A specialist MMC healthcare architect, IBI Manchester, was brought on board early in the process, and that really helps to maximise the control over costs and design by reducing any abortive design work. We have been involved in projects where this has not happened and have ended up inheriting a stage 3 design, which is not as easily compatible, or even able to realise the same benefits. I think if you're using this method to reap the benefits of potential reduced programme and potentially some reduced costs, it's important to bring the design team and contractor early on in the process, i.e. sort of REBA stage 1, 2. Otherwise, it can ultimately lead to going back and redoing the design. So we still had to go through the process. We covered everything we would do in a traditional build project, but at speed. We fixed the frame early and the overarching metre squared, while also working with clinical leads to understand what works well now and what could be improved. We also visited an MTX live site, which was nearing practical completion, which really actually alleviated concerns around the quality of this type of building, specifically the flooring and the response factors. And this brought the clinical team fully on board with this form of construction. We looked at lessons learned from previous projects, including thoughtful and repeatable spaces. The clinical team had previously visited other ICUs across the country and also further afield. If you could just click on that would be great. Through a couple, thank you. In addition to the standard guidance that was just about to come up on the slide, we were able to weave in key learnings from this and previous pandemics. At the time of this project, we were involved in multiple ICU type projects in the UK and also across the globe, as well as the Birmingham Nightingale. My colleague at the time, Suzanne McCormick, hi Suzanne, I know you're listening, was key in tying this emerging best practice and knowledge together. If you could just click through, please. Thank you. Next slide. So in addition to the best practice guidance, we looked at the literature. This showed that patients in multi-bed areas were 4 times more likely to be recorded as delirious than those in single rooms. And on the other hand, anecdotally, that we know that nursing is often easier and staff retention and well-being is much improved within a multi-bed environment and is generally preferred by staff due to line of sight and colleague support. Line of sight was paramount on this project, and although all the beds were classed as level 3 and require one-to-one nursing, we know that in the pandemic this isn't always possible, and that ICU nurses may have to look after more than one patient at any one time. If you could just click through to the next image, thank you. We also know that the ICUs are noisy with equipment, staff, ventilators, alarms, and they're almost always above recommended health organisation standards for sound. And this can cause or contribute to delirium and post-traumatic stress disorder for patients. For us, it was about finding a balance between patient well-being, staff well-being, IPC, and ultimately that reduction of travelling sound by having different types of accommodation. In this case, there was 20% isolation rooms with lobbies, an additional 10% single rooms on top of that, with the remaining 70% in multi-bed bays. Interestingly, the fire compartmentalisation throughout the building also helped to create acoustic control. We also included feedback from patients and families from within the ICU environment. So that included things like optimal placing of the clinical hand wash basins away from the patient head to reduce the noise. That also included things like improving the level of patient dignity and the ability for them to observe incoming staff with the patient head away from the door. And then this also working into reducing the noise levels from incoming staff and the door mechanism. In terms of FF&E, we did simple things like clocks facing each patient to enable patients to grasp the concept of time and ground themselves, as it can often feel like they're suspended in time and space while in the ICU. So that was the pre-construction case study, and now on to David for the construction element.
Thank you, Sarah. Next slide, please. So we have some time-lapse footage showing a project that we worked with for the Norfolk and Norwich University hospitals, which provided a total of 98 compliant bed spaces. Okay, thank you. Next slide, please.
So finally, what are the takeaways? So develop your MMC strategy early to avoid realizing that you've ruled out options further down the line. I mean, we would say this, but bring on the MMC team early. Designers, design managers, contractors. It's important to bring them on early to avoid abortive design work and costs. And personally, for me, this is almost the most important point. For the consultants and the clients, be prepared to work a little faster. It's quite the sprint. And then in terms of early clinical and stakeholder engagement, it's integral to flesh out that vision for the project early on. And I guess also from lived experience, it's important to realize that some of these decisions are often more final than in traditional builds, especially when you're designing and manufacturing in parallel and with this project at speed.
In addition to that, there will be the speedy collation of the existing site-specific information to allow us to understand the restrictions and the challenges with the potential build. Consideration also with key stakeholders to the buildability, ensuring patient and public pathways can be maintained is essential. And of course, seek planning advice along with early engagement with BREEAM assessors. Okay, thank you.